What's up? What's up? It's your man Jimmy Chan. All right, so today we're talking about logarithmic functions, which is actually the inverse of an exponential function. So here's an exponential function here. As you notice that here's my graph, right? It always crosses 0, 1, 1, comma A, whatever that A might be. And in fact, it would be this A right here. So I probably should erase this and call those B instead, since I just wrote this equation right here. And B right here, okay? Oops. Let's change that to green, right? So because that this base right here is B, it will be whatever that B is. So anything raised to the first power, B raised to the first power is B, right? B raised to the -1 power will be 1 over B because B is not happy being on top, so it goes to the bottom, all right? So I can raise this to a negative power. It's just going to be less than 1. It's going to be between 1 and 0, or 0 and 1, all right? But it's not, this exponential function is never going to be negative, however. So that's the reason why the range is from 0 to infinity without being 0, and it definitely can't be negative, all right? So if the logarithmic function is the inverse of this whole thing here, that means to find the inverse, we would switch the x and the y. So if I was to look at this equation right here, if I was to switch the x and the y, then I'll have this right here, all right? This is the exponent form of a logarithmic function, all right? And we'll get to this part, log form, in just a sec. But let's talk about switching the x and y. Well, it's not just switching the x and y. So if you look at the points, when I switch the x and y's, this will be 1 over b comma -1, or 1 over a in this case. Again, I should probably change these as well. So let me go ahead and erase those and bring this b over here, because 1 over 1 comma b would now be b comma 1, and -1 comma 1 over b will be now 1 over b comma -1, and 0, 1 will now become 1, 0 because I switched the x and the y, right? I have horizontal asymptote at y equals 0. If I switch the y for x, now it's going to be x equals 0, which actually becomes a vertical asymptote. And not just that, my domain and range would be switched as well, right? So my domain was -infinity to positive infinity. That means my range now would be -infinity to positive infinity. My range was 0 to infinity. Well, now my domain is going to be 0 to infinity. So not just my x and y switch, but my domain and range also switch, because my domains are all my x values and my range are all my y values, right? So with that being said, however, this is telling me that I can never take a log of a negative number. So we got to be careful with that. Any x values that would force me to take the log of negative numbers cannot be used, okay? So we got to be very, very careful about it. Which, so again, I can't have negative x values, which makes sense, right? Because b raised to any power should never give me a negative value. Makes sense. All right, so how did I go from here to here? Well, a couple of things I do, right? One of the ways to remember how to convert from exponential form to logarithmic form. So again, these both right here are both logarithmic functions, just in exponent form and log form. So how do I go from one to the other? So the way I do that is this. Ready? Let's take a look. So let me change this to a different color so that it's a little bit easier to see, okay? So no matter if I'm looking at this b right here or this b right here, b on both ways or both forms are called bases. I call this log base b of x, and this is a base b raised to a power. So no matter how I put it, the b is always called a base, okay? So with that being said, this base right here says, you know what? The grass looks greener on the other side. I've been your base for so long. I want to try and be the base on the other side. So, like any job, if the only worker there for a boss, for someone in power, is gone, the person in power would have to now come down to the floor and actually work, right? This is now a base on this side. In order for this to be the base of this side, what would have to happen is that the log would need to come in. Okay? So hence I have this right here. All right? And the same happens vice versa, right? So if this base is here saying, ooh, I've been with you for so long, and the grass looks greener on the other side, so I want to be the base on the other side. So it comes over and becomes this base. Well, if someone comes in and you're the boss and someone comes in and say, I want to work for you, you're going to say, okay, great. Now I can go upstairs and be a boss. So this guy won't shrink. Okay, there we go. So it becomes a boss and your base is now down there working. Well, when this side, when the log says, oh my goodness, my base is gone, it goes away, and now I'm back to the so-called exponent form. Okay, so that's one good way of going from log form to exponent form. All right, so that's how I would tell you to do that. All right, however, log has several different forms. What you have here is a log of some base, log with some base of something, okay? So it always has to take the log of something. It's kind of like me writing a square root. Well, just writing the square root means absolutely nothing. Just me writing a squared doesn't mean anything without a base or without, let's say 3, or without some number in here, right? Without squaring something or taking the square root of something, the symbol itself means absolutely nothing, just the symbol itself. So when we take the log, we have to take the log of something. A regular base has a base, right? However, what if you look on your calculator, you only see just a regular log. And you can take the log of something if you want to, right? This is still log form, but when there is no base written here, it's assumed to be a 10. Okay, so it's assumed, let me put a parentheses here. So this is assumed to be a base of 10, okay? And these are called the common log. Okay. Now, what if the base wasn't 10 or wasn't a number and it was just a letter E? Well, E stands for is the natural number. So we could write y is equal to the ln of x. Well, this right here is saying that this is the same thing as saying log base E of x, meaning the base is E, which is the natural number. So I should probably write down E. E is the natural number. Okay. More importantly, this is called the natural log. All right. So going to need bigger parentheses here. There we go. All right. So these are the 3 different forms. All right. Now let's do some problems based on this. So what are you going to be asked to do when it comes to this? Well, one is going to be converting, right, logarithmic functions from log form to exponential form. And vice versa. And you're going to have to be able to do exponential form to the log form. So for example, let's say I have log base 3 of 5 is equal to c. Well, I have a log here. That means I have a log form. And I need to bring this to the exponential form. So again, I look at this, right? The 3 says, log, I've been your base for a long time. I'm going to go over here and be their base because the grass looks greener. And the log is so depressed that it kind of goes away. So now this right here, 5 is equal to 3 to the c would be my exponent form. Okay. Or I could be given, let's say, let me see, b raised to the 4th power is equal to 24, okay? And I gotta convert this to a log form. Since there's no logs in here, it must be the exponent form, so I want to go to the log form. So same thing, I take this, and the base goes, Mr. 4, Mr. Power of 4, I've been your base for so long, I want to go over to the other side and be their base. So 4 needs to come down, and then now log has found a purpose of being a log. So now this is going to be 4 is equal to log base b of 24. Okay? So that would be my log form. And that's how we would convert from log to exponential form, or to exponent form to log form. All right? Now we might have to evaluate also. All right? So if I had, let's say, log base 2 of 16, what we would do is say, okay, let's say that this is equal to y. So then I would say, okay, so what we're going to do is we're going to convert it over the exponential form because it's easier to then solve for it, right? Since we got to evaluate. So the 2 is a base of log, says I want to be the base of the other side. There we go. And log is so depressed, it goes away. So that means now I've converted this to this problem here, right? So question is, 2 raised to what power gives me 16? Well, I know that, so let me do this, right? I know that 2 to the 4th gives me 16, right? So therefore, y must equal to 4. Okay. Now, the other part of it is that you got to be careful about the domain. Right? So let's say we had to find the domain. And let's say it says, hey, f of x is equal to log base 5 of x plus 1 over 1 minus x. Okay? So here's the thing. Number one, we have a fraction. So we got to deal with that, right? So fraction, right, which is x plus 1 over 1 minus x. Well, this denominator, what I know is that this denominator, 1 minus x, cannot equal to 0. So that means x cannot be 1. So that's a restriction. I got that, right? So let me put this up a little bit and put a comma here. All right, so that's what I got. However, this thing cannot be negative either. Okay, so let's write it this way as a second thing. So x plus 1 over 1 minus x has to be greater than 0. Which means that x plus 1 also has to be greater than 0. Which tells me that x is greater than -1. Okay? So now I have a restriction here and this right here. So if I was to draw this on the number line, right? And so the key point is 1. So let's put 1 here, and let's put -1 here. Okay? So the blue is telling me that I can have this go on to the right forever. However, the red says, no, you can't have that. So that means that this piece right here can only go to here, and then this piece right here. So I can get to 1, but I can't include 1 and then anything else. So my domain is going to be from -1 to 1, union with 1 to infinity. And that would be my domain. All right? Well, I hope this helps. If there's any questions, please let me know. See ya. Bye.